Question 1, question 2, question 3, question 4, question 5, question 6. Then we take a hiatus. Question 7, question 8. 11 questions in the last 7 years from discriminant. Alright, so equation x cube plus 2r plus 1x square plus 4r minus 1x plus 2 has minus 2 as one of the roots. If the other roots are real, then the minimum possible non-negative integer value of r is. So what will we do? We will factorize this. If minus 2 is one of the roots, then what are they saying? That x plus 2 will divide this. Because the roots were what? X minus alpha. Alpha is minus 2. So x minus alpha will come out to be x plus 2. So can someone quickly divide this with x plus 2 and tell me what is going to be the quadratic inside? You will have an x square term. You will have a plus 1 term. This I got easily by looking at this and this. What is going to be the central term? Plus 2r minus 1 x. This seems okay to me because x square will get 2r minus 1 plus 2. That is 2r plus 1. That is correct. X will get 2 into 2r minus 1. That is 4r minus 2. And then plus 1x. So 4r minus 1. So this has real roots. What does that mean? For something to have real roots, what does that mean? That the discriminant is greater than equal to 0. So whenever they talk about roots being real, they are talking about discriminant. So you will simply get 2r minus 1 whole square minus 4 into 1 into 1 is greater than equal to 0. And from this, you can find the integer value of r which will satisfy. You can get the answer from here, the minimum possible value. I think you can just put it here, right? Non-negative integer. If you put 2, you'll get 4 minus 1. That is 3 square minus 4 greater than equal to 0. That is correct. But if I put r as 1, then you will get 2 minus 1 whole square, minus 4, which is 1 minus 4. That would not be greater than equal to 0. There's no trick to do long division. Generally, what you can do is, once you know that x plus 2 is one of the roots, what I quickly did was, I figured that the coefficient of x cube that you have here, it is going to be made by what? The multiplication of x and x square. So because this is 1 and this is already 1, so this will be 1. The constant term will be made by this into this. So the constant term is given to me as 2. I already have a 2, so this will have to be 1. After that, you can assume it to be as bx and then make an equation and find. So you can equate the coefficients. You write it as bx, which is what Harsha did. You write it as bx, then you find the coefficient of x squares. So you will get plus 2 here, plus b, right? This is given to you as 2r plus 1. So from here you will get b is equal to 2r plus 1 minus 2, that is 2r minus 1. So once you have b, you have your long division done for you. All right, moving on. K is an integer such that equation 2x square plus kx plus 5 equal to 0 has no real roots, and the equation has two distinct real roots for x. This has no real roots. So k square minus 4 into 2 into 5 is less than 0. This has two distinct roots. K minus 5 whole square minus 4 is greater than 0. You have to find the number of possible values of k. K is an integer. So pretty straightforward, right? This is going to be what? K minus 7 into k minus 3 is greater than 0. Because this is k minus 5 whole square minus 2 square. So I can use my a square minus b square here. So, even your a square minus, even your identities would not just pop out of the screen. You will have to figure those. So once you have this, you can figure out what are the values that you can take. Everybody clear on this? So the values that you can take is either greater than 7 or less than 3 to get a positive, value of this multiplication. And this will give you the other range. K square is less than 4 into 2, that is 40. So the magnitude of k is going to be between minus 6 to 6. So you just take intersection of this and you will get your answer. All right. In how many ways can a pair of integers be chosen such that x square minus 2 mod x plus mod a minus 2 is equal to 0? First of all, how do I get rid of mod? I'll write this as mod x whole square. So y square minus 2y plus mod of a minus 2 is equal to 0. Secondly, I want the discriminant to be positive here. What will be the discriminant? 4 square minus 4 times mod of a minus 2. Sorry, 2 square. B square minus 4ac. I want this to be greater than equal to 0, or I will get 1 is greater than equal to mod of a minus 2. Now this would be simple. You will get the values of a here. You have only three possible values of a. A can be either 2 or 3 or 1. Anything other than that, you will cross the value 1. Corresponding to this, you can find your roots. So the number of roots that you will get corresponding to all three of these would be 7. You also have to make sure that you are calculating value of mod x. So you will pick the positive root that you will get, and corresponding to that positive root, you will have two values of x allowed, a negative one and a positive one. So this was honestly, a lot of room for making mistakes in this particular question. All right, moving on. X square plus mx plus 2n is equal to 0. X square plus 2nx plus m is equal to 0. Both of them have real roots. What does that mean for me? M square minus 4 into 2n, that is 8n, is greater than equal to 0. This having real roots mean what? 4n square minus 4m is greater than equal to 0. So n square minus m is greater than equal to 0, and m square is greater than equal to 8n. So I can write this as n square is greater than equal to m. Now because m and n are both positive, can I square these? Yes, I can square this. I will get n to the power 4 is greater than equal to m square, which is already greater than equal to 8n. Using this, you can arrive at the values of n, and then you can arrive at the value of m. So you will take the lowest value of n, because that will give you the lowest value of m. So the lowest value of n that I can see is when n to the power 4 is equal to 8n, which will give you n is equal to n cube is equal to 8, or n is equal to 2. Corresponding to that n equal to 2, you will get the lowest value of m as m square is equal to 16, which will give you m is equal to 4. So your answer will be 2 plus 4 is equal to 6. If I add this one and this one, I will get m square minus 4m plus 4n square minus 8n is greater than equal to 0. This is going to be m minus 2 whole square plus 4 times n minus 1 whole square is greater than equal to 4 plus 4, I think 8. Yes. So from here, I can pick the values that I want. N and m are positive. So if n is equal to 1, if I take n is equal to 1, I will get m minimum value as what? M minus 2 whole square is greater than equal to 8, or m will have to be 5. 5 minus 2 whole square. So you will get 5 and 1. If I take n is equal to 2, I will get 4. So m minus 2 whole square is greater than equal to 4. So m, lowest value will be 4. So yeah, you are getting 6, 6. So yeah, this is also a good method. You can do this. All right, moving on. One more question. X square minus 4x minus log a base 2. A is a real number. It has two bits inside log a. Why are they even telling me this? The roots are real and distinct if and only if. Real and distinct, which means b square minus 4ac minus into minus will become plus 4 log a base 2 is greater than 0. Would equality be a part of this transaction? No, because you have been pointed out that the roots have to be distinct. So from here you can cancel out 4 of 4 is greater than equal to minus log a base 2. So from here you can get your answer. All right, one more question. A, B are integers such that 2x square minus ax plus 2 is greater than 0, x square minus bx plus 8 is greater than equal to 0. So they tried to hide the equality, but I saw that. For all near numbers x, then the largest possible value of 2a minus 6b. This seems very trivial, right? I mean, a and b are not together in one equation. So I individually have to find the maximum value of a and the minimum value of b, so that their difference is maximized. If I give you something like capital X minus capital Y, and if I ask you to maximize this, what would be your thought process? I can either increase X, or I can decrease Y, or I can do both. So you will get what here? A square minus 4 into 2 into 2 minus 4, you see, that is 16, is is less than 0, and b square minus 32 is less than equal to 0. So you can find the maximum value of a from here. It won't be 4, it will have to be 3, the maximum value of a, and the minimum value of b square is uh, less than equal to 32. So less than, because this is what is given to you, right? Your quadratic your quadratics are greater than 0 or greater than equal to 0. What is the graph for this? What is the graph for the first one? It will be this, right? A greater than 0 and d less than 0. You will not have an intersection. Having a root would mean that you are reaching a value of 0, and that is something they have explicitly stated is not happening. In this, you can attain the value of 0, but you can't cross it, which means the graph for this can look like this, where you are touching the x-axis. So again, I will have to use the discriminant. You can either talk about that when they ask you for real roots, or when they give you the range of the quadratic by saying greater than 0, or greater than equal to 0 or less than 0, in which case you will need minus a. So these are the two markers for that discriminant is something I have to apply. Clear, Adya? Yes, all right. So the maximum value of a is 3. B square is less than equal to 32. So what is the minimum value of b that you can take? Minus 5, right? Because minus 5 square will be minus 25. If you go to minus 6, this will become 36. Then this would not be respected. So you put minus 5 here and 3 here. You will get 2 into 3 plus 6 into 5. That is 36 will become your answer. F of 1 is x square plus 11x plus n. F of f2x is x. X square plus 11x plus n is equal to x, the largest positive integer n for which the equation has two distinct real roots. So what will you do? You will equate these two. You will get x square plus 10x plus n is equal to 0. And for this quadratic, what do you want your discriminant to do? You want your discriminant to be greater than 0, because you want two distinct real roots. So 10 square minus 4n is greater than 0, or n is less than 25. So what is the answer? N is equal to 24. Quadratic and range thing. Range and your h of x thing. So x square plus 2x plus 4 divided by 2x square plus 4x plus 9 is equal to y, which means x square plus 2x plus 4 is equal to 2yx square plus 4xy plus 9y. Now if I write it back, I'll get x square times 1 minus 2y plus x times 2 minus 4y plus 4 minus 9y is equal to 0. The discriminant for this quadratic in x should be greater than equal to 0, which means 2 minus 4y whole square minus 4 times 1 minus 2y into 4 minus 9y should be greater than equal to 0. So you can solve this and you will get your answer, but there is a better method here, which is to convert this, function by function thing into some constant plus 1 by function, or some constant k1 k2 by function, because then the question would remain, can you maximize or minimize this denominator? I'll show you what I mean. X square plus 2x plus 4 divided by 2x square plus 4x plus 9. Can I write this as 1 by 2 times 2x square plus 4x plus 8 divided by 2x square plus 4x plus 9? Can I write it like this? I can. Can I write the numerator now as 2x square plus 4x plus 9 minus 1 divided by 2x square plus 4x plus 9? And when I separate this, will I get 1 by 2 into 1 minus 1 by 2x square plus 4x plus 9? Now, if I want to find the range of this, function, this is your expression. I've just written it in such a way. See, this is a minus term. If I can minimize this minus term, will I get my maximum value? To minimize this 1 by function format, should you maximize the denominator? So you can just go ahead and maximize the denominator. It's an upward facing quadratic. So the maximum value is always going to be infinite, and 1 by infinite is 0. So you have a value of 1 by 2. If you want to, maximize this expression, would you minimize this denominator? And what is the minimum value of this denominator? At what point will it get the minimum value? At minus b by 2a, which is minus 4 by 4, which is minus 1. So you put minus 1 here, you will get 2 minus 4 plus 9, that is 7. So 1 minus 1 by 7, which is 6 by 7, which is going to be 3 by 7. So your 3 by 7 to 1 by 2 is going to be your answer. The maximum was 1 by 2 and the minimum was 3 by 7. The 1 by 2 will have a, curved, because infinity is something, you can't really achieve. So 1 by infinity would tends towards 0, would not exactly be 0. So that is the difference between having a square bracket and a curved bracket. So fx is a polynomial of degree 49 such that f of 1 is equal to 4, f of 2 is equal to 5, f of 3 is equal to 6. Have you spotted the pattern yet? What is the pattern? F of x, for this pattern only, for let's say n, I am saying n, not x. The pattern is x plus 3. So what is the function that I will define? The function that I will define will be f of x minus x plus 3. What are going to be the roots of this function? F of x minus x plus 3. See, f of 1 is 4. So when I put 1, I'll get f of 1 as 4 and I'll get 1 plus 3 as 4. 4 minus 4 is equal to 0. Same thing you will get for all the inputs that they have given me. So the roots are 1 to 49, which means h of x, and I will, h of x, which I can write as k times x minus 1 into x minus 2 into x minus 3 till x minus 49. This is equal to f of x minus x plus 3. Can I now put x as 50? Basically, I will ignore, I will, this intermediate function that I had defined, I will now remove that. Can I say this is the value of f of x? K times x minus 1 till x minus 49 is equal to f of x minus x plus 3. So you put 50 here. What is this? K into 49, 48, 47 till 1. So this is 49 factorial is equal to f of 50 minus 53, or f of 50 will turn out to be k times 49 factorial plus 53. 3x square plus lambda x minus 1 is equal to 0. There is nothing novel going to be here. This is going to be, the sum product expression which plus the identities that we have memorized. It is going to be a combination of these two things. This is a no brainer sort of situation. So alpha beta are the roots of this equation that satisfy this. Okay, let us look at what alpha beta are satisfying. Can I write this as alpha square plus beta square is equal to 15 alpha square beta square? I can do that. Do I know what alpha into beta is? Yes, I know what alpha into beta is. It is minus 1 by 3. So the square will be 1 by 9. So this entire thing is 15 by 9 or 5 by 3. Okay, now before I jump the gun and go on to find the exact values of, alpha and beta, let us just first focus on what they have even asked me. They have asked me alpha cube plus beta cube, which is alpha plus beta into alpha square plus beta square minus alpha beta and the whole square of this thing. This is what they have asked. So I know alpha square plus beta square. I know alpha beta as well. I need to find alpha plus beta. How will I find alpha plus beta? If I have alpha square plus beta square available, can I convert this into alpha plus beta whole square minus 2 alpha beta? This is equal to 5 by 3, which means alpha plus beta whole square is equal to 5 by 3 plus 2 times alpha beta, and alpha beta was minus 1 by 3. So this is going to be 5 by 3 minus 2 by 3, which is going to be 1. So alpha plus beta whole square is 1. So can I just remove this from here? because it is getting whole squared. So all I'm concerned with is this expression. So alpha square plus beta square is 5 by 3, and alpha beta is uh, minus 1 by 3. So this thing is getting squared, which is 6 by 3, that is 2 square, which is 4. So the answer for this question is going to be 4. Yes? All right. Nothing complicated here. Just the expression values that you know, what is alpha plus beta, what is alpha beta. Now you just have to convert everything into that. Alpha beta are two distinct roots of the equation 2x square minus 6x plus k. Alpha plus beta and alpha beta are the two roots of this equation. Then find the value of 8 times k minus p. So first of all, what is alpha plus beta? Is it 3? Alpha plus beta is going to be what? Minus b by a, which is 6 by 2. What is alpha beta? Is it k by 2? Now these two are the roots of this equation. So can I say that 3 plus k by 2 is going to be minus p, and 3 into k by 2 is going to be plus p? Is it a linear equation in two variables? Or rather it will be opposite. So let us just add. I'll get 3 plus 2k is equal to 0, or k is equal to minus 3 by 2, which would mean p is equal to minus 9 by 4. This seems correct, right? K is equal to minus 3 by 2 and p is equal to minus 9 by 4. And this is something I can now just substitute back. 8 into minus 3 by 2 plus 9 by 4, which is going to be 4, 6, 9 minus 6, 3, 3 by 4 into 8. Next one. Quadratic equation x square plus bx plus c equal to 0 has two real roots. The difference between reciprocal of the roots is 1 by 3. So 1 by alpha minus 1 by beta is equal to 1 by 3. Sum of the reciprocals of the squares of the roots is 5 by 9. So 1 by alpha square plus 1 by beta square is equal to 5 by 9. You have to find the largest possible value of b plus c. What is going to be b plus c? Is it going to be minus alpha plus beta plus alpha beta? Because minus b by 1 is what? Alpha plus beta. So this is what I have written, right? So 9 times alpha square plus beta square is equal to 5 times alpha square beta square. And from here I will get 3 times beta minus alpha is equal to alpha beta. Now, how can I further reduce this? Is the question. Because I don't really uh, have a formula for difference of roots, right? You don't have a formula for the difference of the roots. So what I want to get rid of is the difference exactly. And the best way to do that is if I square this. If you square this, what will you get? 9 times beta square plus alpha square minus 2 alpha beta is equal to alpha square beta square. This is something you know, right? Basically you now have equations in alpha square beta square and alpha square beta square. So you can get the value of alpha plus beta, and you can get the value of alpha beta from here, and that should give you your answer. Yes, everyone's clear on this? So this thing that I don't know, there is no set expression for difference of the roots. I mean there is. If you want, you can write the root as minus b plus under root b square minus 4c here, and minus b minus under root b square minus 4c divided by 2 divided by 2. So if I take the difference, I will end up with what? Under root of b square minus 4ac. Right? I mean, there is an expression, but it has so much more here. You might as well just square and solve. After this, you guys can solve, I hope. Yeah, so for this, you have basically sum of the roots minus b. Uh, can you guys hear me?
यस
Yes,
सर,
sir.
अब आ रही है.
Yeah. Okay. So the sum of the
ऑल्सो
roots
सर,
is going. Yeah. हाँ
सॉरी टू
हाँ,
इंटरप्ट, वो
I saw
DLR
that. I
क्लास
saw that.
कैंसिल हो गई.
I saw that. I saw that.
ओके.
All right. So the sum of the roots for this quadratic is going to be minus b, which is 4a plus 3a, that is 7a. And the product of the roots c by 1 is going to be 4a into 3a, which is 12a square. So b square is going to be, 49a square, or b square plus c is going to be 61a square. So out of the options, you have to find the multiple of 61 because a is going to be an integer. Furthermore, you might have other options as well. You might have, more than one options being, divisible by 61. For example, 427 is, I think, 61 into 7. Yeah, but 7 is not a perfect square. So you also need a perfect square as well. So this is going to be the marriage of both these things. So which of these options can be represented as 61 into a square, a being an integer? That is the question. All right, I think one or two more here. So common given roots is also a fairly straightforward condition that they have. They will give you two quadratic equations, uh, and maybe a third one, and they say they have a common negative root. So in these situations, your focus should be on finding the said root. For example, let's say that common root is alpha. Would that mean that alpha square plus m alpha plus 9 is equal to 0? Would that also mean alpha square plus n alpha plus 17 is equal to 0? And would that also mean alpha square plus m plus n alpha plus 35 is equal to 0? Now, looking at this, it feels very, natural. We should add the first two and then subtract the third one, which will get me rid of all the alpha terms. So I will get 2 alpha square minus alpha square, which is alpha square. These would cancel out. And I will have 9 plus 17, which is 26, minus 35, which is minus 9 is equal to 0, or alpha is equal to 3 plus minus. Now, because they have said the common root is negative, you get alpha as minus 3. Now, you need to find the value of 2m plus 3n. So, that is simple. You just put x is equal to minus 3 here. You will get 9 minus 3m plus 9 is equal to 0. You have the value of m. You put alpha is equal to minus 3 in this equation. You will get 9 minus 3n plus 17 is equal to 0. So, you have the value of n from here, and this you can then use in this expression 2m plus 3n. So 3n is directly given to you as 26, and m you can find from here. Clear? So again, it's a fairly straightforward question. If they are saying you have a common root, just put it and find the root. I mean, you have three equations and only three variables, so you can solve it, right? The variables are what? M, n, and alpha. So you can find each of these hypothetically. Uh, fx is a quadratic polynomial in x such that f of x is greater than equal to 0. If f2 is equal to 0 and f4 is equal to 6, then find the value of f of minus 2. Now, immediately from this, my observation is that this is going to be like this, where this point is 2. Correct? Uh, so I can just write this as a times x minus 2 whole square, because a quadratic that has its minima as 0, it is going to be what? A quadratic which has minima at, a minimum value of 0 is going to be what? It's going to be just touching. And doesn't just touching mean that the roots are repeating? And does that not mean the quadratic can be written like this? So you can write it like this. You just put x equal to 4. Using this, you will find the value of a. And then once you have the value of a, you can put minus 2. All right. Okay. Range and graph. A, B, C are non-real numbers such that B square is less than equal to 4AC. This is directly talking about discriminant without taking its name. F of x is equal to ax square plus bx plus c. If the S set S consists of all the integers m such that f of m is less than 0, then the set S must necessarily be. Now, this is a good question because it tests, a lot of concepts. You can either have this as your graph, or you can have this as your graph. Correct? Both of these are possible because they have not commented on the sign of A. Right? Because discriminant is less than 0, b square is less than 4ac, it means that you will not intersect the x-axis. If this is the red graph, would you be less than 0 for all integers m, set of all integers? But if you are in the black graph, when your a is greater than 0, you will never be less than 0. So you could either be this or this. So your answer will be option number c. This is a good logical question without having you do, strenuous calculations, etc. All right, moving on. The minimum possible value of the sum of the squares of the roots of the equation x square plus a plus 3x minus a plus 5. So, what is the sum of the squares of this root? Will it be a plus 3 whole square minus 2 times alpha beta, which is going to be minus a plus 5? Basically, s square minus 2p you will write. Correct. S is what? A plus minus a plus 3 by 2. So a plus 3 whole square. What is product? It is minus a plus 5. So this will become plus 2a plus 5. Is this a quadratic? Yes, this is a quadratic. This is a quadratic in A. They are asking you for the minimum possible value of this. A square will not cancel. This will become a quadratic in A. Let's just make it a square plus 6x plus 6a plus 2a, that is 8a, plus 9 plus 10, that is 19. I think this is the quadratic that you will get, correct? All right. Now you want to find the minimum value of this quadratic. Can I just put minus 8 by 2 into 1 as value of a? Can I put a as minus 4 here? I will get my answer from that, correct? 16 plus 19, that is 35, minus 32, your answer will be 3. Okay, f of x is a quadratic expression with a positive number coefficient for x square. What have they given me? A greater than 0. If the roots of f of x equal to 0 lie in the interval minus 1 to 1, then which of the following is necessarily true? This is minus 1, this is 1. The parabola is going to be upward facing. Now, are they talking about one root or are they talking about both the roots? Both the roots, right? If the roots, both the roots are lying between minus 1 and 1. So let's say one of the roots is this, the other root is this. However you draw it, once you cross it, you will continue to cross. So both of these values will be greater than 0. Both of these values, value at minus 1 and value at 1, it is going to be greater than 0. So that is going to be option number 1. These sort of questions, it's best to do with graph. If they had said that one of the roots, only one of the roots lie between minus 1 and 1, then what could have been the condition? Then the condition would have been minus f of minus 1 into f of 1 is less than 0. I mean, in this format it would have been multiple possible, either 2 or either 4, or they could have given it like this. Because if only one root lies, then it will have to be something like this, right? It crosses the x-axis only once between these two. So once it's positive, then negative, or negative and positive, the product would be negative. This is a quadratic ax square plus bx plus c with a is greater than 0. Now, they are asking you for how many distinct pairs alpha and beta is f of 0 less than 0. What is f of 0? If I put x is equal to 0, will I get c as my output? Wasn't c the intercept? They're talking about the intercept, right? They want intercept to be less than 0. So you want this to be less than 0. Now, if c is less than 0 and a is already greater than 0, would c by a become negative? A negative number divided by positive, which is going to be what? Alpha into beta. C by is what? Alpha beta. So basically what they are asking you is that select alpha and beta in such a way that the product of alpha and beta comes out to be negative. So you have, these options here: minus 4, minus 3, minus 2, minus 1, 0, 1, 2. And for beta you have minus 3, minus 2, minus 1, 0, 1, 2, 3. So if alpha is from this range, then beta will have to be from this range. And if alpha is from this range, then beta will have to be from this range. So 4 into 3 plus 3 into 2, that is 18 will be your answer. All right, great. So finally, we are in the special forms question. X plus 1 by x is a very, very, common sort of questions that is, eventually asked. Somewhere you do end up seeing this. The idea is simple. You will convert this back. X to the power 8 plus 1 by x to the power 8 plus 2 is equal to 47 plus 2, and this will become x to the power 4 plus 1 by x to the power 4 whole square, which is equal to 49. Now, if you take under root, you will get x to the power 4 plus 1 by x to the power 4 is equal to 7. So, you brought your x to the power 8 equation down to x to the power 4 equation. You will again do the same thing and you will get to x square. So, you will get x square plus 1 by x square is equal to 3. You will do this again. You will add plus 2 again, then take under root. You will get x plus 1 by x is equal to root 5. At this point, you have everything you need. X to the power 9 plus 1 by x to the power 9. This is going to be what? X cube plus 1 by x cube into x to the power 6 plus 1 by x to the power 6 minus 1. Correct? Basically, a cube plus b cube formula. Now you can find this by cubing and then you can find this by further squaring it. So this is the set template for these sort of questions. If it is asked, you add 2 and you reduce the complexity. From 8 you get to 4, from 4 you get to 2, and from 2 you get to x plus 1 by x. And after this, you can cube this. You will get x cube plus 1 by x cube, and then further cube it, you will get x to the power 9 plus 1 by x to the power 9. All right. I hope this is clear. The second one is this: the number of distinct real roots of the equation x plus 1 by x to the power 2 minus 3 times x plus 1 by x plus 2 is equal to 0. Uh, I'll take it as y. Y square minus 3y plus 2 is equal to 0. This is factorizable as y minus 1 into y minus 2 is equal to 0. What a simple question, cat. Thank you. I will mark 2 as my answer. What is wrong with that? They want you to think it like that. Because when you took y as x plus 1 by x, does my favorite, does my favorite, thing come into the picture? Yes, AMGM. Can x plus 1 by x ever be equal to 1? Can y be equal to 1? No. So this is not going to be the root. X plus 1 by x is equal to 2 is the only root, which means x is equal to 1 is the only root that you will get. So, this is a sort of question that probably, I would have made just for some, just for the sake of some laughs. Make it so easy, but put AMGM, just there so that people end up making mistakes. All right. The next special format question is this: x square minus 10 raised to the power something. Basically, a function to a function power is equal to 1. There are three cases to this. If x square minus 10 is equal to 1, then doesn't matter what is happening in the power, 1 to the power anything is going to be equal to 0. If your power is equal to 0, then it doesn't matter what is the base, your outcome will always be 1. If your base is equal to minus 1 and corresponding to that your power, which is x square minus 3x minus 10, if that is even, then that will also be allowed. This is the special case which is usually missed. So x square minus 10 is equal to 1. Will that give you any integral solutions? No. X square minus 3x minus 10 is equal to 0 will give me integer solutions as x minus 5 into x plus 2. Right? So 5 and minus 2 are going to be two values from here. Here I will get x square is equal to 9 or x is equal to plus minus 3. At 3, what is the power? Odd minus even. So odd minus odd, even minus even, even. That is correct. Same for minus 3. Odd, even. So odd minus odd, even minus even, even. So I don't need to calculate the exact values. I don't want to get to that, level. I'm clear on plus minus 3 also been allowed. So this will have four answers. Usually people miss out on this particular, choice. Next question in the exact same format. So CAT has asked this in 22, asked this in 2020, and asked this again in 2020 in one of the slots. So you have a quadratic to a quadratic is equal to 1. The approach is same. This equal to 1, this equal to 0, or this equal to minus 1, while this is even. So can this be equal to 1? X square minus 7x plus 10 is equal to 0. Yes, it can be x minus 5 into x minus 2. So I will have two roots here. If I take the numerator, if I take the power as 0, will you have integer answers there? 42 is 6 into 7. So x minus 6 into x minus 7. So you will get 6 and 7 also as your answer. So I'm getting 2 from here as well. If I put this equal to minus 2, minus 1, I'll get x square minus 7x plus 11 is equal to minus 1 or 12. So x minus 4 into x minus 3. So 3 and 4 will also be allowed. I will have to check if this is becoming even or odd. So for even, this will be even minus even plus even. So even, that is correct. So 4 is allowed. And for odd, it will be odd minus odd, which is even plus even. So it will still be even Steven. So this will be 2. So total 6. The reason why I tried to, again solve this for you is there just might be a situation where one of the roots within that repeats. Maybe here you were getting x 6 comma 3, then the distinct values would have been 5, not 6. Correct. So that is another safety check that you should do. You can go on and find the exact values of x, satisfy yourself that they are distinct. All right, 1 last, x square minus 5x plus 7 raised to the power x plus 1. This is x square minus 5x plus 6, so which is x minus 3 into x minus 2. So this will give you two values. X plus 1 is equal to 0. So x is equal to minus 1 is also going to be a value. Finally, just check for the odd minus 1 thing. So x square minus 5x plus 8 equal to 0 will give you nothing, right? 5 square minus 32, it's going to be imaginary. So x square minus 5x plus 7 is equal to minus 1 cannot be attained for a real value of x. So that is going to be ignored. So not possible. So you had only three. One final special format is your conjugate roots. So, just like imaginary roots, because they were happening with real plus imaginary, if you have something which has under root of, a number which is not perfect square, your root will be of the format rational plus irrational. The other root will be rational minus irrational. So it is a good way for them to give you information. So they have said that 3 plus 2 root 2 is a root of this equation. So it is understood that the other root is 3 minus 2 root 2, which means I have been given the values of b and c here. If you think about it, b by a and c by a. Similarly, 4 plus 2 root 3 is a root of this equation, which means the other root is 4 minus 2 root 3. So using these, you can further solve, you can further find the value of this expression. So the conjugate root thing is used very slyly. They will give you one of the roots and they would expect you to know the other root. All right. So same thing here, ax square minus bx plus c, one of the root is 2 plus root 3, which means the other root is 2 minus root 3, which means the sum of the roots is 4 and the product of the root is 4 minus 3. That is 1. So sum of the roots is given, product of the roots is given, and they are saying that sum of the roots is, they are also giving b is equal to c cube. So then you can use all of this. B is equal to minus 4a and c is equal to a. You will substitute this and you will get the value of a from here. Actually, b is plus 4a because you have a minus sign here. If I give you a polynomial f of x and I say that boss divide this with x minus alpha, tell me what is the remainder. The remainder is going to be the value of the function when you put alpha as an input. This is as straightforward as this. If I'm dividing by x minus alpha, just put alpha in the function, whatever is the output, that will be your answer. However, if I'm dividing with something which is not x minus alpha, let's say it is x square plus something, then we have to make some adjustments. The adjustment will be, I will assume the remainder function to be 1 degree less than this. So whatever I am dividing with, I will assume the remainder function to be 1 degree less than this. So if I'm taking this as quadratic, I will take this as linear, basically mx plus c. If I'm dividing with a cubic, I will assume the remainder as ax square plus bx plus c, basically a quadratic. Let's say if you're dividing with a cubic. Once you have done this, you will then start putting the roots. So if they were dividing with x square plus, let's say they were dividing with x minus 3 into x minus 4. You put the value of x as 3, you will get one remainder as 3a plus c. You will then put x is equal to 4, you will get another equation in 4. You now have two equations, two variables, you will be able to solve. If it's a cubic, then you will assume the remainder to have this format, ax square plus bx plus c. Then all it remains for you is to find the value of a, b, and c. Your answer will be of the format ax square plus bx plus c. And the values of a, b, and c is you can find by the information that is given. So the only thing of note would be that the power of the remainder will be 1 degree less than the divisor. So this is divided by x minus 1 leaving a remainder of 4 divided by x plus 1 leaving a remainder of 3. So what will I do? If I'm dividing by x minus 1, I will put x is equal to 1. So I'll get 1 minus a plus b minus c plus 8 is equal to 0 is equal to 4. This is the value when I'm putting x is equal to 1, and that should be equal to 4 because it's the remainder. The same thing I will do with minus 1. So I'll get 1 plus a uh, plus b plus c plus 8 is equal to 3. If I add the two equations, a and c will cancel out. I will be left with b. Yes? All right. Now alternating out. This was not a PYQ. Alternating output. Basically, if you have roots which are not repeating, your function will go something like this. So between each root, you will cross the function from negative to positive, then from positive to negative, then from negative to positive, and then back to negative. The only way to avoid this at the intersection with x-axis is that you touch it and come back. And touching and coming back is what? Having repeated roots, which is what? Having x minus alpha square situation in your factor format. And this is clear, right? Doesn't matter x minus alpha is negative or positive. On either side of alpha, the outcome will be what? Positive. So the sign will not change. You can have a question on this. Cat had asked f of x is equal to x square plus 2x minus 15 upon x square minus 7x minus 18. They are asking when is this negative. So I will first factorize this. I will write x minus 3 into x plus 5 divided by x minus 9 into x plus 2. The factorization is correct? Yeah. So now I will mark these points. I have minus 5, minus 2, then I have 3, then I have 9. Now before minus 5, all four of these would be negative. So negative into negative divided by negative into negative, which is positive by positive, which is positive. After minus 5, only one of these will change the signs. So you will become negative, then you will become positive, then you will become negative, and then you will become positive. So your answer will be between minus 5 and minus 2 and between 3 and 9. So option C. However, if the factorization was this, x minus 3 into x plus 5 whole square into x minus 9 into x plus 2, what I would have done is I would have disregarded the 5 completely. I would have written it as minus 2, 3, and 9 only. The 5 does not matter to me. Yes? Clear on this, everyone? I mean, At x is equal to minus 5, it would have gone something like this. That is fine with me, but it would not have been, crossing over. So it would have still been negative, negative. Yeah. Clear, everyone? Can we move ahead? Is there any conversation going on, Tushar? All right, okay. I think you are satisfied within yourself. Okay. Finally, the last thing I wanted to discuss was symmetry. If I say that a function is symmetrical around this point, what that mean is that even the roots would be symmetrical. So let's say you are symmetrical around this, then this distance and this distance would be equal. This distance and this distance would be equal. So if you are symmetrical, you are completely symmetrical. Now, being symmetrical around something means what? Let's say this value is d. This is x is equal to, let's say, d. This is going to be what? D minus L. What is this going to be? D plus L, because you are symmetrical. If I add the x coefficient of both of these, what will I get? D minus L plus D plus L is equal to what? 2D. Basically twice the coefficient of this. So the coefficient of your symmetry axis is what? Half of the sum of the roots that you had. Correct? Now this also does not have to be root. It just have to be the same value. For example, the value, let's say I give you the point that at x is equal to 1, your function, symmetrical function, is 6, and at x is equal to 3 also the function is 6. Can you tell me around what it is symmetrical? It's going to be 1 plus 3 by 2. Same argument. Because you have same output, the distances would be same. So 1 plus 3 will be 2 times t. So this was a question that CAT had asked. F of 5 plus x is equal to f of 5 minus x for every real x, and f of x is equal to 0 has four distinct real roots. Then the sum of these roots is what? Now, can you see that this is symmetrical around x is equal to 5? Because you go any distance, an x distance after 5, the output will be same when you go x distance before 5, which is 5 minus x. So the function is symmetrical around 5. So let's say this alpha and beta are the one root, so alpha plus beta is going to be what? 2 into 5, this coefficient. The other two root sum will be equal to what? 2 into 5, and overall their sum will be what? 10 plus 10, which is 20. Yes.